Hi students, welcome back to the new session. In this session, we are going to discuss about the concept of electronic configuration and the rules pertaining to the concept of electronic configuration. As you know well, we have three different rules or principles pertaining to electronic configuration. Before that, we should know what is electronic configuration and who proposed this concept of electronic configuration. Okay, so what is electronic configuration? Electronic configuration in the sense the order of filling up of electrons into various atomic orbitals of a given atom is called, I am writing simply EC, nothing but electronic configuration. The order of filling of electrons into various atomic orbitals of a given atom is called electronic configuration. This concept of electronic configuration was first introduced by Niels Bohr. Okay, the concept of electronic configuration was first proposed by a scientist called as Niels Bohr. This was credited to the scientist Niels Bohr. Understood? So, sir, what are different principles or different rules, okay, pertaining to this electronic configuration? That we will discuss now. Okay, now the different principles are related to this concept of electronic configuration we are going to discuss are first one is Aufbau Principle. Okay, according to Aufbau Principle, before that, what you should know, what is the meaning of Aufbau? Aufbau means adding up or building up. Adding up or building up, nothing but surely this is a building up. According to Aufbau principle, electrons always occupies the orbitals having least energy first. According to Aufbau principle, electrons always occupies the orbitals having least energy first. According to Aufbau principle, electrons always occupies the orbitals, nothing but atomic orbitals, having least energy first. In the sense, the orbitals are having higher energy, they will be occupied next. So initially, according to Aufbau principle, electrons always occupies the orbitals having least energy first, then only they enters into the higher energy atomic orbitals. Okay, so now we'll be discussing this with a suitable example. Before that, we should have some basic idea about Moeller's diagram. Okay, and before even about Moeller's diagram, we should have minimum idea about atomic orbitals. We have basically in 10th level, primarily we are going to study about three different atomic orbitals. First one is s orbital, next is p orbital, next is d orbital. Okay, now s orbital, you know well, it is having a spherical in its shape, and p orbital is dumbbell shape and d orbital is double dumbbell shape. Okay, it is having a double dumbbell shape. Okay, so in s orbital, maximum number of electrons, in s orbital, maximum number of electrons is only 2. Okay, and p orbital, maximum number of electrons is 6 electrons. Okay, and d orbital, maximum number of electrons is 10 electrons. So, as you know, the general outermost electronic configuration of our s orbital is ns2. Okay, ns2. Here n means type of shell, s is a subshell, we know that is orbital, and 2 is a number of electrons. And s orbital starts from, that is, it starts from first shell. that is n is equal to 1, nothing but a k shell. And next, like that, if you take the example of for this SR plus charge from first shell, it means 1s2, maximum number of electrons, I mean 2s2, 3s2, like that, and so on. Next one is p orbital. Now, p orbital shape is a dumbbell. In p, we are having a 3 degenerate orbitals are there. S does not have any degenerate orbitals, only one s orbital. Okay. Now, in p, next to p orbital, maximum number of electrons is 6. Okay. And general electronic configuration is np6. And if you write half filled configuration is np3. And for this one, half filled configuration is ns1. In P, we are having a 3 degenerate orbitals, 3 suborbitals are there. There you know that Px, Py and Pz commonly named as. And P orbital starts from second shell. Remember this. If it is in second shell means I will make it as 2px, 2py, 2pz. Okay, this px, py, pz orbitals of P orbital are called degenerate orbitals. And here also, if the p orbital is in second shell, it is 2px, 2py, 2pz. All these 3 orbitals are called degenerate orbitals. What is the meaning of degenerate orbitals? The orbitals of same energy. The orbitals of same energy are called degenerate orbitals. Okay, so p orbital, the shape is dumbbell, and maximum number of electrons in p orbital is 6 electrons. And we are having a p, three types of degenerate orbitals are there. They are px, py, pz. What is the meaning of degenerate orbitals? I told orbitals of same energy are called degenerate orbitals, whereas s does not have any degenerate orbitals. Only one type, that is only if it is s orbital is in first shell, it is called 1s, second shell means 2s, 3s, 4s and so on, depends upon number of shells. Okay, and p orbital, maximum number of electrons is 6. General outermost electronic configuration is np6. Okay, and half filled configuration is np3. And p has got 3 degenerate orbitals. They are commonly named as px, py, pz. As you know, p orbital starts from second shell, nothing but a L shell. Second shell and then L shell. Here it is first shell means K shell. And in 2px, 2py, if it is second shell, 2px, 2py, 2pz, each containing 2 electrons on an average. That is 2 electrons, 2 electrons, 2 electrons. That is 3, 2, 6 electrons. Sir, maximum electrons is 6. It may be less than that, depends upon atomic number of the respective element. We are going to write the configuration. Next, if I talk about d orbital. Now, d orbital is having a double dumbbell shape, and I wrote already here, d orbital is having a double dumbbell shape, and the maximum number of electrons in d orbital is 10 electrons, and d has got 5 degenerate orbitals. They are dxy, dyz, dzx, dx square minus y square, dz square. So general outermost electronic variation is simply nd10, and d starts from third shell. D orbital starts from third shell, and if it is third shell means 5 types are there. I told no, that is 3dxy, 3dyz, okay, 3dzx, 3d x square minus y square and 3d z square. Understood? So each containing 2 electrons on an average, that is 5 into 2, 10 number of electrons are there. If you take total number of electrons, all d orbitals, d suborbitals together, 5 are there, and total number of electrons is 10 will be there. I hope you understood these. Next, even we have f orbital, j orbital, vagera may come. Okay, but primarily we are going to study about 3 degenerate 3 orbitals with degenerate orbitals having only for p and d orbitals. So there is no degenerate orbitals for s orbital, only one type, and maximum number of electrons is 2. I told as it is. Okay, now next one is we are going to discuss about Moeller's diagram, because you should have some basic idea about Moeller's diagram. So Moeller's diagram, if you have any basic idea about this Moeller diagram, we can write the configuration of the elements very easily, and we can able to understand the principles pertaining to electronic configuration. So I want to draw this Moeller's diagram. So Moeller's diagram, before I draw the Moeller's diagram, I will, for example, if I take one atom having some nucleus, that is, this is the first shell, second shell, third shell, fourth shell, and so on. This is n is equal to 1, this is n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 4, n is equal to 3, n is equal to 2, and also named as K shell, L shell, M shell, N shell, and so on. Okay, if I draw the Moeller's diagram, now before that, sir, how many number of electrons are present in a given shell according to Bohr's concept, Bohr's model of atom? To find out the number of electrons present in a given shell, to find the number of electrons in a given shell or orbit of Bohr, we can use the formula 2n square, total number of electrons, 2n square. Now, if I take n is equal to 1, if I substitute n is equal to 1 in this first shell, that is for first shell, if I substitute to n is equal to 1, 2n square means 2 into 1 square, how much? 2 electrons are there. That is 2 electrons first shell. Second shell means, second shell, if you substitute 2 into 2 square, okay, it will become 8 electrons. Third shell means 2 into 3 square, nothing but 3 3 is 9 into 18 electrons, and so on. Like this we can calculate. Sir, okay, we understood this. Then how to find out the number of sub-energy levels or orbitals present in a given energy level or a given shell means we can use the formula n square. This is used to find out the number of orbitals in a given orbit, that is n square. Now if you take n is equal to 1 first shell, substitute that, n square is equal to 1 square, how much? 1. So here we are having, in the first shell we are having only s orbital, no p orbital. Now if I take n is equal to, n square is equal to 2 square, nothing but 2 to the 4, that is 4 orbitals are there. In that, 1 s orbital is there, and 1 s orbital, I will write here 1 s orbital and 3 p orbitals. Nothing but they are degenerate orbitals, px, py, and pz are there. So 1 plus 3, how many total? 4. You got 4. Is it clear? You got a value 4 here. That is, here is 1s, next is px, py, pz. And sir, if you go the third shell, sir, how many orbitals are there in that? Means n square, nothing but that is 3 square, nothing but 9. So here how we will write, sir? Means in this we have, I will rub this part, then I will explain for that. And so here if you take 9 means 1 s orbital is there, not 1s, there is s, and 3 p orbitals are there, and 5 d orbitals are there. So this is as usual 3s, third shell means this is 3px, 3py, 3pz, and d we are having a 3d, 5d orbitals now, 3dxy, 3dyz, 3dzx, 3dx square minus y square, and 3dz square. So 1 plus 3 plus 5, how many total? 9. You got 9 orbitals. I hope you all understood. Next one, after this, we will be discussing about Moeller's diagram. You should keep this particular thing in mind, because if you don't have idea about this particular, how you got the number of electrons, how you got this, how many number of orbitals are there in a given orbit, or how many number of sub-energy levels are there in a given energy level. If you don't have idea, we can't write the configuration easily. So to make it easy for you, I explained this part first. Next one, we'll be discussing about Moeller's diagram. Moeller's diagram, we know as usual, we are having a first shell contains only s orbital. If s orbital comes under first shell, it is called as a 1s. Now, here I am taking the, according to azimuthal quantum number or angular momentum quantum number, the value of L starts from L is equal to 0, 1, 2, 3, etc. So if L value is equal to 0, the orbital comes under this is s orbital. If L value is equal to 1, the orbital comes under this p orbital. If L value is equal to 2, the orbital comes under this is d orbital. So majorly in the board examination, chance of asking electronic configurations to write maximum up to 30 elements. Okay, most of the times 20. If any tough paper is there, means chance of getting up to 30 elements. So you should have basic idea about 30 elements at least for this SSC, that is a 10th class, both for AP and Telangana students. Okay, next one. So if L value is equal to 0, azimuthal quantum number value or angular momentum quantum number value is equal to 0, So L denotes type of subshell. Here we are having subshell is L is equal to 0 means S subshell S orbital. L is equal to 1 means P subshell, that is P orbital. L is equal to means D subshell, that is D orbital. I hope you all understood this. Okay, now, sir, N denotes what, sir? N is nothing but principal quantum number. N denotes principal quantum number, nothing but which gives rise to type of shell. N is equal to, if I say N is equal to 1, 2, 3, 4, etc. Because N is equal to 0 does not exist. Okay, N is equal to 1 only. So this tells about type of shell. N is equal to 1, first shell, 2, second shell, third shell, fourth shell, and so on. Now I'm going to, please remember this. Okay, I'm going to draw the Moeller's diagram based on these particular values and related to orbitals. Now I will take L values here. L is equal to 0, 1. Okay, and you can write for each and every step. L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3, and so on. Understood? Now here initially here N value N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, N is equal to 5, N is equal to 6, and so on. Now first of all we are having the orbital called S orbital, which is S subshell. Okay, L is equal to 0 means S orbital, N is equal to 1, L is equal to 0 first orbital, N is equal to 1 first shell. So that is 1s. Next L is equal to 0 and N is equal to means that is 2s. Here is 3s, here it is 4s, here it is 5s, here it is 6s, and so on will come. And next if I go with the next one, L is equal to 1, N is equal to 1, L is equal to 1, N is equal to 1, N is equal to 1, P orbital does not exist. Whereas N is equal to P orbital, N is equal to means second shell, L is equal to 1 means P orbital, P orbital exists from second shell, that is 2p, third shell means 3p, 4p, 5p, 6p. Next L is equal to 2 means D orbital, that is it starts from N is equal to 3 third shell. So that is here is 3D and we are having is a 4D, 5D, 6D. Next one is L is equal to 3 if I write. The orbital starts here is F orbital, the fourth shell N is equal to 4, L is equal to 3 means F orbital, that is 4F, 5F, 6F, and so on. So then order of filling up of electrons, how the electrons are going to fill in the respective orbital means, first electrons always orbitals having least energy 1s, then into next energy level 2s, next is 2p 3s, next is 3p 4s, next 3d 4p 5s, and 4d 5p 6s, and so on. Is it right? So we have, if you wish to write, you can write more, but it is sufficient for you people to write for in the board examination. We are having up to only d orbital 30 elements are there primarily. So hence I'm explaining, I'm more focusing on these only. Okay. Now after filling 1s, the orbital, after filling 1s orbital, the electron is going to enter into 2s like this. Please, while you are drawing the diagram, please be careful, then you will understand the 1s. After finishing 1s, they are going to enter into 2s. After 2s, 2p, 3s. Next after that, okay, 3s, 3p, 4s. After that, 4s, 3d, 4p. So remember this. Now if I write, okay, if you know this diagram, then we can able to write the order of increasing order of the energy levels of atomic orbitals, that we can write more easily. Then I will explain about it. I will draw. Okay, I will draw that one. Now we are having is among all these orbitals, least energy is 1s orbital. 1s increasing. Okay, filling up of electrons in increasing order of the energy levels. First is 1s. Next one is we are having is 2s. 1s is less than 2s. 2s is less than 2p. 2p is less than 3s. 3s is less than 3p. 3p is less than 4s. 4s is less than 3d, and so on. Like that will come. After 3d we are having is, next we can write 4p. Okay, 4p is less than 5s, and so on. Like this we can now write. And sometimes this may be asked, chance of asking either in bit part in a different way or maybe in 2 marks. We can't say exactly this will come, that will come. Maybe chance of asking, hence you have to prepare even for any kind of a question if they ask. Okay, I hope you understood up to here. Next, after this, we are going to discuss about the principle, that is nothing but Aufbau principle. Before that, For clear understanding purpose, I explained all these things. I hope you all understood. You are happy with my explanation. Next, I told you about Aufbau principle already. According to Aufbau principle, Aufbau in the sense building up. For simple understanding purpose, adding up. According to Aufbau principle, electrons always occupies the orbitals having least energy first, then only enters into higher energy levels. Okay. Now, according to Aufbau principle, electrons always occupies the orbitals having least energy first. For example, we give one example of element like go with the lithium. Lithium atomic number is 3. Okay, it contains 3 electrons. We least bother about protons here, no, because we are writing electronic configuration. We nothing to do with the protons here. The protons is related to atomic mass number or atomic weight concept. Now, we are not discussing about protons here. We're discussing about only electrons. Lithium has got 3 electrons are there. Okay, in these 3 electrons, how these 3 electrons are going to fill? First, the electron enters into 1s level. I told you s orbital maximum number of electrons is 2. P orbital maximum is 6 electrons. D orbital maximum electrons is 10 electrons. So, order of filling up of electrons. Okay, first electron enters into 1s level. So, we have maximum 3 electrons are there here. So, s orbital can able to accommodate maximum 2 electrons. Those in these 3 electrons, 2 electrons will be first filled in 1s level. After out of 3 electrons, 2 electrons are filled in 1s. How many electrons left means only 1. Okay, now that 1 electron comes under 2s. Okay, 1 electron. Sir, you told S has got maximum 2 electrons now. So you wrote only 1, sir. You are wrong. No. I am not wrong. I'm perfect in this regards. Because we have only 1 electron left in this. Out of 3, we wrote 2 already. 1 is left, that was filled in 2s orbital. I hope you all understood this. Next, I will go with the element like nitrogen. Nitrogen atomic number is 7. Okay, nitrogen atomic number is 7. It contains 7 electrons. So 7 electrons are there. Now I will be filling those electrons. 1s. I told you s maximum number of electrons is 2. Okay, 1s. After 1s out of 7 you got already 2. How many left means 5. So next we are having is 2s level. That is 2s2 completely filled. Next out of 7 you already got 4. How many left? How many left means 3 are left. I am going to fill those 3 electrons in p orbital, that is 2p3, because I told already p has got maximum 6 electrons. It can able to accommodate maximum 6 electrons, not more than that. So we have only 3 left. Just we are filling directly into 2p3. Okay. So sir, you told some degenerate orbitals in regards with the p na. No, we don't have discussion here. We'll be having the discussion in Hund's rule. Okay, I hope you all understood this. Next, I will go with one more element like calcium. I will go directly. No, I can't go directly. Then I will go to another example, simple example. That is, I will go with aluminium. Aluminium atomic number is 13. It has got 13 electrons. In these 13 electrons, sir, how these electrons are filled, sir? Now, we know as usual, 1s2. Out of 13, you got already 2. And next one is 2s2. Okay, next after that, p maximum 6, na, 13. In the 13, we already filled 4. Next, I will write 2p6. 2 plus 2, 4 plus 6, 10 you got already. How many left we are having is 3 left out of 13. We wrote already 10. 3 left. After 2p, what we are having a 3s here. I am filling completely 3s level, 3s2. So we got 12. Only 1 is left. After 3s, what we have the orbital is 3p. That 1 electron will be filled in p orbital, 3p1. I hope you all understood this. Okay. Next, we are having a next element. What I am going to tell about the element like is a calcium, and after that, very important 2 elements I will be discussing. Okay, calcium. Calcium atomic number is 20. It contains 20 electrons. It contains 20 electrons are there. So I will write directly. If you have any doubt, okay, you can comment in the comment section in between while watching. 1s2, 2s2, 2p6, 3s2, 3p6. Up to here we got 18. Okay, so 3s2, 3p6 over. What is left? We are having is after 3p, we are having the 4s. 3p6 and next directly I am filling 4s2. Is it clear? Please remember how to write. Please have a practice of all these configurations. Not only these, all 30 elements. Now I am going to after 20 elements, primarily first initial we'll go with the element like scandium, and next I will go with the chromium and copper, which are much important. And scandium atomic number is 21. It contains as usual atomic number, directly tells about number of electrons in that. Okay, So we can't define directly atomic number is nothing but number of electrons. No, number of protons present in a given atom or number of electrons present in a neutral atom. Okay, so that is scandium atomic number is 21. 21 electrons are there. Will the configuration 1s2, 2s2, 2p6, 3s2, 3p6, and here is 4s2, 3d1. So up to here is 20 and this is a 3d1. And we can write in some books it may configuration may be given like this. Okay, up to these configurations mentioned as argon, 4s2, 3d1. This is also right. Argon 4s2, 3d1. Argon means up to here 18. Argon atomic number is 18. So we can make it as argon 4s2, 3d1. This is also right. Okay. So next one is very, very important configurations which we are going to discuss. Chance of asking the board examination, rarely coming the question. Okay, that is configuration related to chromium and as well as a copper. Chromium element, chromium atomic number is 24. Okay, it has got 24 electrons. Okay, 24 electrons. Configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4 I am writing. Okay, this is not much acceptable. This configuration, sir, if you count we are getting 24 now, sir, it is right, sir. Okay, according to you it is right, but we can go the one more way, very important way, stabilized way. So I want to make the atom more stable, and there is initially the configuration should be more stable. So the elements with the orbitals with the half filled electrons or fully filled electrons are more stable. Now, if I say the configuration of general electronic configuration of p orbital, that is np6 completely filled. Half filled means np3. 6 means in 6 half means 3 na. So it will be stable, and it is stable. It is much stable. D is also stable. And D, if you take maximum number of electrons is 10. General configuration is nd10. Half filled is nd5. So this is much stable, and this is also stable. So I want to indicate the stability of the respective configuration. So what I write this configuration, I will modify this one as up to here is same only, but instead of these, I will make it as 4s1, 3d5. So this configuration is more stable than this. Hence, we are going to follow this, and remaining all the part is this part is same only. That is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. In the same way, we are having the element called as a copper. Copper atomic number is 29. Its 29 electrons are there. Okay, 29 electrons are there. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Okay, but it is not a perfectly suggested configuration to write like this. The best way is we make it a half filled 4s1, 3d10. Perfectly stable configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Okay, I hope you all understood these configurations. Sir, so we heard one more concept related to Aufbau principle, that is about n plus L values, sir. So Aufbau principle n plus L values, in the sense, now we are going to write the configuration based on that. One question is there. Okay, why the electron enters into 4s orbital? I will write one question and I will solve that. Why the electron enters into 4s orbital? 4s orbital. Okay, but not into 3d orbital. Okay, in case of an element nothing but scandium, which atomic number is 21. Now I will show the configuration, then I will explain about it. So configuration of scandium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now, sir, why the electron enters into 4s orbital but not 3d? Sir, if you see here, 4s is in 4s, 4 is a bigger number, and 3d, in 3d we are having 3 is a smaller number. Na? Electron is supposed to enter into 3d. Now, why it is entering into 4s? Why not into 3d? You may get one doubt. So for this kind of concepts, okay, we have to consider the n plus L value. n plus L will be considered. Now I'm going to write the n plus L values. That is for 4s orbital and 3d orbital. I'm going to write n plus L value. I hope you already know about what is L, what is L. N denotes type of shell, L denotes type of subshell. Okay, that is orbital. Now here if you write in this 4s and 3d orbital, n is how much here is for 4s orbital, that is a 4. For 3d orbital, n is how much? 3. Now you know well, L is equal to 0 means which orbitals I told? S orbital. L is equal to 1 means which orbital I told? P orbital. Now if I take L is equal to 0, S orbital means L is equal to 0. Now D means L is equal to how much? That is now L is equal to 2 means which orbital? D orbital. So D orbital means L is equal to 2 value. Then I will write 2. 4 plus 0, 4. And here is how much? 3 plus 2. 3 plus 2 means how much? 5. So which is having a less n plus L value? 4s orbital is having less n plus L value. So if this kind of problem comes, means we need to check with the n plus L value. So according to Aufbau principle, the orbitals having least energy, the electrons will enter into the orbitals having least energy first. So in terms of n plus L value, the orbital which is having a less n plus L value, into that particular orbital the electron enters first, sir. If any two orbitals are having the same n plus L value, sir, please explain about that one, sir. Now I will take this only as an example, here only. Now I will take the n plus L values for 3p, 4s and 3d. We can take here only, no need to go with another example. Okay, now we are having a 3p orbital, 4s orbital, 3d, n plus L value. Now here for 3p orbital, n is equal to how much? 3. For 4s orbital, n is equal to how much? 4. For 3d, we are having a 3. Now L value for p orbital, 3p means p orbital, L value is how much I told? 1. Now for 4s orbital, in s orbital, L value is how much? 0. For in 3d, we are having d, L is equal to 2 means which orbital I told already, it is there here. That is a d orbital, here is 2. Now if I add all, it is 3 plus 1, 4, 4 plus 0, 4, here it is 5. Sir, here 3p orbital, 4s orbital has got same n plus L value, sir. Then how we have to consider here? Means if you get the same values, if any two orbitals are having same n plus L values, then we have to opt the orbital which has got least n value. So among 3p and 4s, n is having a less n value. N is equal to 3 is there for 3p. For 4s, n is equal to 4 is there. So hence we have to opt this one. The orbital with the less n value, into that the electron enters first. Hence I wrote 3p first, then only 4s, then only 3d. I hope you all understood this Aufbau principle. Very, very easy principle. Enjoy the examples while you are solving in practice sessions. Okay, please copy these. If you like my explanation, please like, share and subscribe.